welcome to Purple Shirted Nerd. We're taking a look at arithmetic sequences today. We're going to find some sums and some terms and some formulas and hopefully show you some processes that can be helpful to you. This is problem number 22 from our textbook. Find the formula for the nth term of an arithmetic sequence. And when I'm dealing with sequences, I always try to see if I can come up with what the next term would be. There's a big hint here in that we're dealing with arithmetic sequences, which always have a common difference. So as we take a look at this, we are going down by 5 and down by 5 and down by 5, etc. So our common difference is 5, or negative 5 in this case. So to find the nth term, we need to take a number of steps from our first term to get there. Let's take a look at this one. Here is term number 4. This is fourth term, is this guy right here. From our first term 10, it is 1, 2, 3 steps to get there. So I think it's a very, very important concept that the number of steps from the first term to the nth term is always 1 less than n. Or if we have 100 terms, there are 99 steps from the first term to the 100th term. So if each step requires me to subtract 5, I subtract 5, I subtract 5, I subtract 5. Another way of thinking of that is that I'm taking multiple steps of subtracting 5, or multiple steps of adding negative 5. So where do I start? I start at 10 and I'm adding multiple steps of negative 5. Again, how many steps to the nth term? Well, how many steps to the fourth term? 3 steps to the fourth term. How many steps to the 100th term? 99 steps to the 100th term. So how many steps to the nth term? N minus 1. And at that point, we could go ahead and distribute and combine terms, but we'll pass that on to a freshman to do for us. We're beyond that. Okay, let's take a look at a similar problem. This is number 26 in our textbook at Hananiga. Find the formula for the nth term of an arithmetic sequence. How does this differ? Well, I'm given a 5th term and a 10th term. I probably am ultimately going to want to know the first term. I probably need to know my common difference as well. Sometimes when we're just starting these problems, just looking at them for the first time, we might want to do something along this line. I've got up to 10 terms, so 1, 2, 3, 4. 5th term, 190, 6, 7, 8, 9. 10th term, 115. With that, I believe we can find the common difference. I'm going from 190 down to 115. So my difference is definitely negative. How big of a negative number are we dealing with here? Well, how many steps from the 5th term to the 10th term? Well, to get from 5 to 10, I have to take 1, 2, 3, 4, 5 steps. So 5 steps get me from 190 to 115. How far do those 5 steps, how much distance do they have to cover? Well, 190 minus 115 is 75. We cover a distance of 75 in 5 steps. If this is arithmetic and every step is the same, then each step should be 15, but don't forget, we're going down negative 15. Okay, so there's our difference. Again, we probably want to know our first term. So our first term, we have to move from our 5th term 1, 2, 3, 4 terms backwards. So it stands to reason if we're moving from right to left and subtracting 15, we're moving from left to right and adding 15. So our first term should equal 190 plus 4 steps of 15. Our first term is 190 plus 60, 250. That's the information that I need to come up with a formula for the nth term. How do we do it? Our nth term is, what are we starting at? 250. How many steps are we taking to get to our nth term? N minus 1. How big are our steps? Careful. Negative 15. All right, not so bad. Problem number 30. You get a lot of these problems throughout this chapter. Write the first 5 terms of the arithmetic sequence. We've got a 4th term, we've got a 10th term. Let's try to do that without our little chart we just used. How many steps from the 4th term to the 10th term? 6 steps. 6 steps to increase by 30. Therefore, each step is 5, and we're getting bigger, so D is positive 5. Probably could go back to our first term now. How many steps from our 4th term backwards to our first term is it? 3 steps back. Our backward steps would be negative 5, so our first term equals our 4th term 16 plus 3 steps of negative 5. Our first term, therefore, is 16 minus 15, 1. Now, I could come up with a formula for this, but if my steps are by 5, no problem. First term 1, second term, go up by 5. Third term, 11. Fourth term up 5, 16. Well, we already had that one, so that checks. And fifth term, of course, 21. Not too bad. What's the big concept here? In my mind, the big concept, you've got 2. We want to deal with steps, how many steps we take, and we want to make certain that we're getting our difference to be positive or negative. Similarly, number 36. Find the first 5 terms and the formula for the nth term of the arithmetic sequence. And here's a guy that we looked at in the last section. This type of definition is called recursive. I always think of it as a ladder. This tells us that on step 1 of the ladder, we're at 200. And we want to climb up the ladder 5 terms. So our first term is 200. This tells us that any step on the ladder is equal to the previous step minus 10. In algebraic form, that would be A2 equals A1 minus 10, or in this case, 200 minus 10. Do we have to go through the algebraic process? Well, we're going to deal with some recursive definitions that are a little bit more complicated than this, but this one's pretty simple. If we think of it, instead of reading this AK plus 1 equals AK minus 10, there's no meaning there. If we think of this as a term is always equal to its predecessor minus 10. So if my first term's 200, it stands to reason my second term is 190. 180 is 10 less than 190. 170 and 160. Thinking of a recursive definition as a ladder and what steps we have to take, in this case we step by reducing 10. If I know A1, A2 is A1 minus 10. It costs me 10 to move up the ladder. Not too bad. Recursive definitions are used all the time, and boy, do they sure make me want to grab Excel and work some spreadsheets with recursive definitions. There's a lot of real world applications that we'll be seeing soon.